Okay, let me give you guys another example. So here, find the gradient of this function here at x equals 1. So start out by sketching the graph. I've done several videos on how to sketch graphs. So if you don't understand this, watch one of the earlier videos. So start out by sketching this graph here. So when x is small, when x is small, it wants to do this here. So it's pretty much a straight line with the intercept of -7. So a straight line with an intercept of -7 and a gradient of +5. So it will look something like this. So this here will be -7 and it has a gradient of +5. Now when x is big, it wants to do this here. So it wants to do a positive quadratic. So maybe something like this, and then something like this. It wants to do a positive quadratic. So now joining everything together, your graph will look something like this. Okay, hang on, let me just tidy this up. So your graph will look something like this. Now we want to know the gradient. We want to know the gradient at x equals 1. We want to know the gradient. Find the gradient at x equals 1. But we don't know where 1 is. 1 is probably somewhere over here, somewhere over here. We don't know. But let's just set up. Let's just find out the gradient first. Okay. So set up 2 points. Let's just anywhere. It could be anywhere. Let's choose. Well, this point here is A. Set up this point here, B. Okay. So draw our right angle triangle here. Now, the gradient that exists between, well, don't forget, this here is x, and this here is x plus h, where h is from here. Well, where h is the length of the base of the triangle. Okay. So so set up something like this. Well, start out by sketching the function. And then set up this system here. Okay, and then you can say that the gradient that exists between A and B, the gradient that exists between A here and B here is given by this. Okay, the gradient that exists between A and B is given by this here. But the thing is, the true gradient is when you get when you keep on decreasing h here. When you get B, the true gradient exists when you get B to move closer and closer and closer towards A. But the way you get B to move closer and closer towards A is by you decreasing h. It's by you decreasing h, and so that eventually h will get to 0. So anyway, the gradient that exists between A and B is given by this here. But the true gradient is when you start to take the limit. Okay, so the gradient that exists between A and B is this. But the true gradient is when you get when you keep on decreasing h so that h heads towards 0. Okay, so the true gradient is given by this here. And remember, so once you're So the true gradient is given by this here. Remember that our function above is this here. Okay. Now so if you look at this here, you got to get the function where you got to get f of x plus h, take away f of x. Okay. So when earlier we had something like this. You see, this height here, well, the gradient is this height divided by this. This height here is really f of x plus h, take away f of x. Okay, I've done several videos on this. So if you don't understand this part here, watch some of the early videos. So hang on. So remember, our true gradient equals this here. And then I'm saying, remember from above that our function is this here. So when you then have to put x plus h into here, meaning that you've got to put x plus h in here and in here. Remember, this 7 here doesn't contain x, so x plus h plays no part for this bit here. Okay, so when you put this into here, it will become 3, and then, well, don't forget you've got to get the bubble, square it first, and then times 3. Because look, you've got to get the bubble, square it first, and then you times 3. And don't forget you've got to put this into here. Okay, so that's why the bubble here times 5. Because look, the bubble times 5. But our bubble is really x plus h here. And then the 7 stays the same. There's no x here, so the 7 stays the same. So this whole thing here is this whole thing here, and then we've got to take away f of x. Well, f of x is our normal f of x here. Okay, so the whole thing here goes into here. And remember that this is like minus a bubble here. That's why we've got squared brackets here. We've got minus a bubble here. Okay, so later on you've got to get this this and then times this and then times this. So later on this will become a positive 7 later on. Okay. Well, anyway, we started out by saying the gradient that exists between A and B is this. But then the true gradients, when you keep on decreasing h, so that eventually it will get to 0. So our true gradient is this here, and then we start putting this into here. Well, anyway, from here you would get to here. Okay. Now it looks complicated, but it's just a matter of tidying it up. It's pretty much straightforward in a way. It looks complicated. So remember, looking at this bit only here, you've got to square this first and then times 3. Okay. So when you square this, it will become this. Try to be able to square this inside your mind without well, it is in effect you doing this. Hang on. It is in effect you doing this. Because this thing squared will be this times this, which is x squared. This times this will be blah blah blah, and it will give you this here. Okay. So and then the 5 here, this times this times this, blah blah blah, and then this whole bit here is this bit here. The 7 stays the same. Okay. And I've done this in one go here. So it's here. This then becomes minus 3x squared. This here will become minus 5x, and then the minus and the minus 7 here becomes a positive 7. Okay, and then this times this times this, and so on. And then so this whole bit here becomes this bit here. Okay, hang on, let me clear this up. So so the next step is to notice that this here will kill off. Well, these two will cancel each other out. They will kill each other off. And then this negative 5x here, you've got a positive 5x here. They're going to get killed off. And then you've got a negative 7 here and a positive 7 here. So they're going to get killed off. So this then becomes this. You've got 3, 8, well, blah, blah, blah. This one here is this one here. So now you see, if you look at these 3 terms here, h is in common, h is in common, h is in common. So factor out the h. Okay, factor out the h. So that will give you this, and then they're going to kill off each other, giving you this. Okay. So now at this stage here, take the limit as h approaches 0. You see, as h approaches 0, this here, when h gets to 0.0000, well, as the limit as h approaches 0 here, this thing here is gonna disappear. Okay, leaving you equals the true gradient equals this. Okay, so the true gradient is this. Okay, so now let's go back to the start. So the start here, we started out by sketching our function here. Remember that we worked out the true gradient to be this here. So when you draw a graph of, when you plot this graph here, it will look like this. The blue line. So remember, hang on. Remember, we worked out the gradient to be 6x plus 5. So when you sketch a graph of 6x plus 5, it will look like this. Okay, the blue line. Now, looking at our original function here, which is the red line here. Let's just say let's just look at when x equals minus 2. When x equals minus 2, now looking at the gradient here, you can see is a negative gradient. So now let's look at the gradient graph at x equals minus 2, which is here. The gradient is, you can see the gradient is minus somewhere around here. I don't know, I'm going to guess 7. The gradient is, it's minus 7. Going back to the graph, hang on. Going back to the graph, let's look at this bit here. So so when x is minus, I don't know, 0.2 or whatever, minus 1.2. Let's just say around here. Around here, you can see that, let's just say at this point here, the gradient is negative, but it's not as steep as up here. You see, up here, looking at the gradient only, the gradient here is still negative, but it's not as negatively big as this point here. So when you look at the gradient graph, you can see down here, the gradient is really high and negatively high. When it's around here, let's say 1 point something, so 1 point something minus 1 point something is around here. You can see that the gradient is still negative, but it's not as shallow, it's not as steep as over here. You see, my point here is that looking at your, so yeah, when you look at these 2 points here, the gradient here is still negative, but not as steep as the gradient up here. So that gets reflected on, it shows up on the gradient graph. So when it's negative, the steepness around here is still negative. The steepness around here is not as steep as somewhere over here. Over here is minus 12 something. The steepness over here is minus, I don't know, minus 3 or 4. And then looking at this function here, at this point here, you can see that the gradient is 0. So when you look at the gradient graph, you can see at this point here, you can see that the gradient is 0. And then let's look at when x equals 0 here. So this is your original function here. When x equals 0, you can see that the gradient is like this. Okay. Well, looking at the gradient graph, when x equals 0, so when x equals 0 here, the gradient is 5. And you can see that. So at the moment you've got gradient. You can think of it as gradient equals this thing here. Okay. When x equals 0, if you want to know the gradient at x equals 0, put 0 into this thing here. Because at the moment you've got gradient graph. At the moment you've got gradient equals this. Now if you want to know the gradient at x equals 0, then put 0 into here. So 6 times 0 is 0, so the gradient is 5. Okay. The original question was find the gradient at x equals 1. Well, at the moment you've got gradient equals this thing here. Well, if you want to know the gradient at x equals 1, then put 1 into here. So it will be 6 times 1, which is 6, plus 5. The gradient at 1 will be positive 11. Yeah, positive 11. So the gradient at x equals 1 here. So this gradient here, if you draw a tangent line here, bad tangent line. If you draw a tangent line here, it will have a gradient of positive 11. Okay, so yeah, so hang on. So just remember that this 6x plus 5 thing is really the gradient. The gradient is 6x plus 5. Wherever you want to know the gradient, you just put it into the x. Okay?